Okay, so number one says they give us a time period. I would note that. So particles moving along the x-axis. Okay, I've studied that before, so that's good news. It's not a new problem. Particles position x of t, that's also not a new idea. We've used that before. It's not explicitly given. The velocity is here, so I would note that on my paper. Please notice, whenever we go through an FRQ, I'm trying to model how you should be thinking as you read the problem, like the pace and everything. The acceleration of the particle is given by this formula, and they say x of 0 equals 2. So I've got all the key information. Questions from anyone? Move on. Part A. Is the speed of the particle increasing or decreasing at this time? This is basically a memorized process. I need to go find the velocity, write that down. I need to find the acceleration, write that down. If they have the same signs, the speed increases. The signs are opposite, the speed decreases. So if you have all three boxes, you get 2 points. If you don't have all three, you probably got 0 points, but once in a while you can get 1.
If I didn't say add to equal 5.5 on the speed,
oh, gotcha. So do you say B of 5.5 is this and A of 5? Good. And you just say the speed is increasing because velocity and acceleration have the same sign, 2 points. Yeah, it's plenty good, Julie, because you've already mentioned the time earlier, so that's totally fine. Please.
So if I don't like to mention the time at all in the problem, I miss the explanation point?
Not necessarily, just read exactly what you have written.
So I said the speed of the particle is increasing because the velocity and acceleration are both increasing.
Gotcha. I think they'll give you one of the two,
Okay.
but because they wanted reasons, they want to see you writing down the numbers.
Well, I have the numbers too.
Oh.
At like where the velocity of 5.5 equals, I just, in my like conclusion, I didn't say at
gotcha.
time.
So you do say this.
Yeah.
Oh, then you're fine.
Okay.
Yeah, no worries.
So if I didn't write down the velocity and acceleration, I just said like almost exactly the red box right there, then I would get 1 out of 2.
So you don't have these numbers docked
I
up,
don't have
right?
them.
Written
I
down.
have them like graph.
Like you figured them out. Yeah, they'd probably give you 1 of 2 because you're not quite as strong on the reason as they want. Does that make sense?
Yeah.
It's a good question. Anybody else? Oh, please.
So you specify like, because I didn't always read like the exact number, so I just feel like the negative, then I can make numbers.
Oh, gotcha. I still think 1 out of 2. When they ask the question about the speed increasing, they typically want to see some kind of numeric evidence. So they know you just didn't guess. So probably 1 of 2. Please. If you're gone and didn't pick up the packet, what I would do is probably stay and be a part of the discussion. Come talk to me and I'll give you an alternate thing to do as a makeup. But you really want to be part of the discussion.
Right, well,
I just don't got it. Sorry. Just read that. Anybody else here? Let's find the average velocity of the particle for the time period 0 to 6. This is it. There's nothing else to do. It's memorized fact. 2 points. 1 point if you have the integral. So let's back up here. So 1 point if you have the green box. And then a second point if you have the red box. Please, Julie.
So I integrated the acceleration instead of the velocity. So that, why is it that are you integrating velocity and average?
If you integrate acceleration, you can calculate the change in the velocity. But anytime you want to find the average of anything, so to find the average value of anything, we always integrate whatever we're averaging. Next one. Find the total distance traveled. Straightforward again. You have the blue box, that's 1 point. If you have the purple box, that's the second point. Question? Please, Alex.
So I did something a little bit weird. So I have. Could you take a look at it? I got the same answer. Actually, so this is. So I looked on my graph and figured out the point at which.
They'll give you 2 points. It's faster to remember this, so I would, if that's valid. Maddie?
So I put the absolute value sign on the outside of the sheet, but I still put like right in my calculator to have the right answer.
Gotcha. Yeah, all eyes up here, everybody. 2 points to Maddie, it's a really good question. Yeah, they're pretty particular about notation. And so putting the absolute value bar on this side of the DT is actually wrong. So they'll give you 1 of 2. Anybody else? Okay, next one. It says from 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So I would grab my calculator. Let's see here. Okay, on the calculator, I'm graphing which is which? It's the velocity and the acceleration. But I really only need to look at the velocity right now. Let's turn that off. So here's a graph of the velocity of the particle from time 0 to time 6. They say find the position of the particle when the particle changes direction. The particle changes direction when the sign of the velocity changes. So this is the time when the particle is changing direction. So you need to find the position of the particle at that time. So I would say does anyone know the specific time here? Oh, it's right here. I wrote it down. 5.196. Okay, so if you have this time on your paper, they're going to give you this point right here, because they'll notice that that's how you figured out that time. So if you have this, you get 1 point. Now we've got to use the fundamental theorem. So we write down the integral from 0 to that time of the velocity is equivalent to how much the position changes between time 0 and time 5.196. So that means this integral is equal to position at 5.196, subtract position at 0, rearranging, we would end up with position at time 5.196 is going to equal x of 0, which is 2, plus the integral 0 to 5.196 of velocity. So if you have this integral written down, you get this point. And then if you work it all out on your calculator and come up with 14.135 or 134, then you get the last one. Please, Jacob.
Do I get the integral point if I have that integral measured at 2?
Yes, they'll actually give you the point even if you forgot to add the 2.
Yeah, so it's probably at the point.
Right, so you have this time. So you get 2 out of 3.
Yeah.
Good question.
So I just have this one integral equals course of one side.
Yeah, that's fine. You just
And
put
I
it on
have
the same line.
Huh?
That should be it.
Yeah, all on the same lines, and then I have the equals.
Yeah, you're fine. They'll give you all 3 points on that. Oh, yeah, you're right. Alex.
So if I never said like.
Hey, don't talk so I can hear you.
So if I never said like if t equals 0 at t equals 5.196, but I had that like value like in my integral and stuff and in my like fundamental theorem, do I?
I think they'll give it to you.
Okay.
Yeah. If they see that you were able to find this time, they'll know that that's where you found it. Okay. Based on the scoring here, I think they'll give it to you. Olivia?
So every time you try to find when it changes direction, it's always on velocity when it like goes positive to negative.
Or negative to positive.
Okay, and then if you're given acceleration, then is that how could you figure that out still or no?
Quiet, please. Hey, listen. Hey, don't talk. Two for Olivia, really good question. Hey, Olivia's question is good, and that is, okay, the reason her question is so good, the reason I gave her 2 pebbles is you're asking concept questions. Again, reminding everyone, you don't work problems with the thought that, hey, I know how to do this kind of problem, because you don't know what kind they will give you. So the way she's asking it is perfect. Most commonly, if we want to find out when a particle changes direction, we're looking at the velocity graph. And when the velocity graph changes sign, the particle changes direction. Because a positive velocity indicates travel to the right, negative velocity indicates travel to the left. If I have a graph of acceleration, it's not easy to see the change in direction. So I've never seen them ask that.
Because that's just saying that the velocity is, so then it would say the velocity is increasing or decreasing, not if it's going to the right or left.
I have to look at the chart. Correct. Yeah. When the acceleration is positive, now you know the velocity is increasing, vice versa. Now, one thing you can do, Olivia and everyone else, hey, if I have a graph of position, because the slope of the position is the velocity, I can use that to see when the particle changes direction. Because I can look and say, hey, when the position graph's going up, that's when the velocity is positive. When the position graph is going down, that's when the velocity is negative. So I can I can determine change in position from that pretty easily. Does that make sense? Good question. Next one. So that's the end of number 1. Let's go to number 2.